This is our first ever virtual institute. However, we have 5 years of experience running this workshop face-to-face. We hope next year to run this workshop in both formats. This institute has most of the same objectives as its face-to-face counterpart. We want you to learn more about renewable solar photovoltaic electricity generation and bring what you learned to life in your classroom. One thing you won't do in this institute is install a solar array. Installing a solar array under our very careful supervision really sets our face-to-face workshop apart. Many of our participants tell us it's the most interesting, unique, fun, hands-on experience they've ever had in a workshop. So here's a short video highlighting what you'll do when you come back next year for our face-to-face institute. Pardon me, when we hope you come back next year for our face-to-face institute. We hope you find this to be both educational and an effective teaser. Come to our workshop and you'll get this set of instructions. On this side of the paper, a checklist of things that need to be done in order to safely install our solar array. On this page is kind of an overhead look of how the system comes together. All of the things that are in blue here are done under blue sky. In other words, they're done outside. This is supposed to be the array. This is a junction box that we wire the array into. You'll see that's on the very roof that you'll see in our video production. Also outside is what's called the emergency AC disconnect. This is a place where we can isolate what we do outside from what's inside and work safely on it. What you see in green here is the inside of our building at Commercial Avenue. The wiring from outside comes through the emergency AC disconnect and goes through an electrical sub-panel and a building grid service panel on its way to the electric grid. There's also computer communication here. Let's go right to step 1. Step 1, we want to examine and lock out our power sources before we begin. 1A, visually confirm your PV array is not assembled and not producing power. Here is the shallow pitch roof we are going to be highlighting in this video. As you can see, there's nothing assembled. We're not producing power. Here is the junction box that I referred to a moment ago, where all of the wiring from our system that we assemble out here will be junctioned so that the electricity from it can be conveyed into the building. 1B, lock out our emergency AC disconnect.
In order to install our array safely, we want to shut off the disconnect that's between our photovoltaic array and the building's electrical system. So we'll shut off the disconnect, the switch, and then we'll put a lock, which has only one key, so no one else can turn this on. Now I'm the only one who can take the lock off and turn it on.
1C, lock out the building grid service panel.
This disconnect provides the power for our electrical sub-panel that all of our solar arrays are connected to. So we're going to shut this off so we can work in that sub-panel safely. Once we shut it off, we use Lockout Tag out in order to make sure that it stays off while we're doing that work. So we have a lock that has only one key, and we put it on the disconnect and hold on to the key so that this cannot be turned back on until we're ready for it to be turned on.
And 1D, turn off our circuit breaker at the electrical sub-panel.
I'm shutting off the circuit breaker at the electrical sub-panel for the PV system that we're working on.
Step 2 is to measure the AC electrical potential. in volts to confirm the AC circuit is de-energized at the electrical subpanel. That's right here. And before we do this, we write down our volts prediction, and our prediction is 0 volts.
We're taking a voltage measurement to confirm that the panel, the subpanel where all of our photovoltaic arrays connect to, that it's de-energized. We shut off the main disconnect and we locked it off, and now we'll verify that this panel is de-energized.
Step 3. Install your PV array racking. Torque or tighten as directed.
A key element of our structure to hold our solar array on the roof is the flashing. All the penetrations to the roof need to be sealed so that no water gets through, and the flashing is part of that. We use a lag bolt to go through our base to hold into the structure of the roof, the rafter or the truss, and then that supports a post to which we'll attach other parts. But the flashing goes over that to make sure that it's sealed and no water can get through. This is an old style flashing. Newer versions are engineered very cleverly to make sure that the water has to run uphill before it can go down through the holes that we're making. So new flashings are very highly engineered to make sure no water gets through the holes that we make in the roof. We attach an L foot to each post, and the L feet will then hold the rails to which the modules are attached. The torque wrench will tighten our bolt to a particular torque setting, which we have to set on our torque wrench. We're going to use 15 foot-pounds for this project. And digital versions of a torque wrench are also available. We have our rail attached to our L feet, and I am making the last tightening up the last bolt here with our torque wrench so that we have this all secure. So the rails will hold the modules, the L feet hold the rails, and the L feet are connected to the posts into the roof structure. So that way when the wind comes, it doesn't take our array and sail it away.
Step 4. Map out an efficient module connection arrangement for our PV array.
This junction box on the roof is where our conductors from our photovoltaic array will move into the building and connect to the building's electrical system. So this is going to be the connection point that we need to think about as we're laying out our plan for our modules on the rooftop. This microinverter will change the DC electricity produced by the module to AC. This is designed so we can connect 2 positives and 2 negatives, a positive and negative from each module, so 2 modules connecting into each microinverter. We have a cable that will carry the AC electricity from the microinverter to all the other microinverters and then into the junction box that will go into the building. Our AC cable that will connect our microinverters together will connect into our junction box that goes into the building. And then by laying out this cable on the rooftop, we get a sense of where our module connections need to be this is our limiting factor, the length of this cable. So we'll be able to place our microinverters and then our modules in the spots that they need to be on our roof. Because the positive and negative leads on the module are only about 3 feet long each, we need to make a plan for how we're going to lay the modules on the rooftop before we get onto the rooftop. So we'll draw out our plan while we're on the ground, and then we'll implement it as we put our modules on the roof. We're going to use 10 modules in our array, and we'll use a whiteboard to lay out those modules. We need to have one positive and one negative at the end of our whole string of modules to connect into our junction box if we're doing a string inverter. We're going to use microinverters, so each pair of modules here will be connected into a microinverter, which will be on the rails with the modules. So one positive and one negative from each module will connect into the microinverter.
Step 5 is to install our microinverters. We will match and record the microinverter number to each module on our map.
We've located the microinverters on the rails in locations where they'll be underneath a module, so they'll be protected from the weather, and where we know we'll be able to attach the positive and negative leads from the 2 modules that will connect into each microinverter. Also, we've attached the AC cable that connects all the microinverters together and connects into the building's electrical system. We've attached that to the microinverters and secured it to the rails.
Here is a microinverter, and there is its identification number. That microinverter is going to be shared between these 2 solar modules, so we'll write its identification number in right there, along with the ID numbers of the other 4 microinverters. Step 6 is to install our modules. We'll torque or tighten them properly as directed.
We're using this bare copper wire to bond the metal parts of the rack together that are not intended to have electricity on them. In case that we do have a ground fault and electrical current gets on these metal parts of the system, we're going to create a pathway that goes back into the electrical system in the building, and it's grounding there. We're going to tie all of that together so that if we do have a ground fault that is current going on to the metal parts it's not supposed to, it will cause the circuit breaker to trip. The modules will be attached to the rails with clamps, and we have 2 different styles of clamps. We have an end clamp, which, as it sounds like, goes on the end of the row of modules. And then we have mid clamps, which will hold down a module on either side. These clamps secure the modules to the rails, holding them in place, and also bond all the metal parts of the system together so that if there's a ground fault, we can activate the circuit breaker.
Getting our first module plumb and square on the roof is very important. Wire management is critical. We want to keep our wires away from the elements as much as possible, and we don't want them rubbing on any rough surfaces like a rooftop, so we clamp them out of the way as much as we can. Sun exposure is an occupational hazard to all installers. That's me putting on the sunscreen. What you're not seeing very well is the positive and negative leads from each module are being connected to their assigned microinverter beneath the modules. And everything, as we move along, is being plumbed, leveled, clamped down, and torqued to the proper industry standard. What you won't see here at all at the end is Joel doing steps 8 and 9. I'll highlight those steps later. Step 7, an easy step. Take a picture of our map. That's to make sure we don't lose the microinverter numbers that go with our modules. Insert camera clicking noise here. Step 8, we've installed our modules now. We have to take some measurements and also have to pay attention to wearing personal protective equipment. We will measure the AC electrical potential, in other words the volts, on the electrical cable that will connect our PV array to the junction box. That's right here on the roof. Our volts prediction is 0. Why is our prediction for that electrical cable 0 volts? Everything is wired together. It turns out that for safety purposes, microinverters will not permit electricity to be produced until connected to the grid. The microinverters have to see a grid that they'll be connected to. And indeed, our measurement here is 0. Step 9 is to land or connect the electrical cable from the PV array to the junction box. Here Joel is about to have participants from one of our face-to-face workshops land or wire the microinverter cable into the junction box. We're beginning our connection to the building and to the grid. Step 10, land and torque the wires in our emergency AC disconnect. Remove our lock and turn the switch on. Cue noise of Joel wiring the emergency AC disconnect.
We've wired up the AC disconnect, which is the switch that allows us to shut off the connection between our solar array and our building's electrical system. Now that we've got it wired, we'll turn it on.
Step 11, remove our lock from the building grid service panel. Here inside the building, turn the switch on.
Now that we've got our photovoltaic array connected and all of the wires terminated in our AC disconnect, we are going to turn the power on to our sub panel that our array connects to. Take off our lock and our tag and turn the disconnect on.
Step 12, turn on our circuit breaker at the electrical sub panel. the inverters will start up.
We've turned on the power to this electrical subpanel at our main disconnect. Now we'll turn the circuit breaker on for our array.
Step 13 requires personal protective equipment. We will measure the AC volts on our circuit breaker at the electrical subpanel. Before we begin, we make a prediction. Our prediction is that our volts will be the expected voltage for our building. Here we have another picture of a former participant, this time taking the volts at the electrical subpanel. Our prediction was to get roughly a measurement at the expected voltage for our building. At our Commercial Avenue campus, that's about 208 volts. Let's take a closer look at this. Step 14 is to enter our microinverter information into the web application.
We have 3 different systems that are connected to communication gateways that will allow us to see the information about the output of our systems on the web. The one that we're connecting together is this one, and you can see as it starts up, the LED lights turn green and go steady, indicating that everything is connected.
So now we enter our microinverter identification information into a web app indicating which modules go with which microinverter. If everything works, we'll get real-time information not just about our array output, but about the performance of our modules. And step 15, observe the web application to confirm our modules are producing electricity as expected. Celebrate or troubleshoot. And it looks like it's time to celebrate. Come to our in-person workshop next year and enjoy the experience. And celebrate with us.